All right, let's kick things off. Nihal, do you want to start us off with a quick introduction, or Kelly?
Yeah, sure. Thanks, Daniel. Okay, so good morning, good afternoon, good evening to everybody who's joined in. Thank you so much for joining in today. I realize that it's a long weekend. In fact, I think while the US has a 3-day weekend, India actually has a 4-day weekend going on right now. So I really appreciate all of those who have joined, and you have actually got a really great opportunity to learn some interesting things today. For those of you who are attending an Applied Singularity meetup for the first time, we are a community of people interested in deep tech, primarily artificial intelligence, IoT, and bioengineering. And we try and conduct knowledge sharing sessions, workshops, all of those for our community about once or twice a month. And so this month, we've partnered with TigerGraph to talk a little bit about what graph databases can do for you when it comes specifically to IoT and supply chains. So this is going to be a two-part series. Today, we're going to be talking about supply chain, and then 2 weeks from now, we'll be looking at IoT in general. Some of you had even attended the previous session that we had with TigerGraph, which was last month, which served as an intro. Don't worry if you missed out on that one. I think you'll still be able to kind of grasp most of what is being spoken about today. And it's also going to be a very, kind of example-led this thing. So we're starting with supply chain because that's a very interesting use case for graph databases and what all you can do with it and how you can really leverage the power that, that this whole database schema brings. So once again, thank you all and welcome. And for those of you who are interested in, reading up about the latest in all of these areas, I would encourage you to download the Applied Singularity app. It's available for free on the iOS and the Android app stores. What you can do is go look for Applied Singularity, and you'll find us. We curate content for you, the latest articles, research papers, videos, events, courses, and jobs. And specifically for jobs, we actually have a new program that we're launching. It's just launched, an application are open for this. If you're searching for an AI-focused job, AI, machine learning, data science, any of these, we are currently putting together a job support program. So that means we're not actually going to be teaching you about these skills. There are enough courses, enough YouTube videos, all of that for you to pick up the skills. But if you've already picked up the skills, if you are actively interviewing for jobs, we can maybe help you get to the next stage of that. So our program will include a little bit of support in terms of, how do you prepare your CV better? How do you make sure that you're putting your best foot forward in the interviews? How do you crack the interviews, and a little bit on how can you negotiate for the best possible offer that you can get. This is a free program, but there are only 20 seats available, so I would encourage you to join in as soon as you can. It will follow an application process because we already have quite a few entries, but please feel free to apply. I will be sharing a link to the application form a little bit later today. But for now, let's get started off. I'll hand it back to Daniel, and we can get started with today's session. Please do not forget to also join in for next, the next session, which will happen 2 weeks from now. That's April 30th, same time. Okay, Daniel, over to you.
Great, thank you very much. So today we're going to be touching on TigerGraph for supply chain use cases, or graph in general, rather, for supply chain use cases. We're going to start off with just a quick overview of what graph is and how it's different from the databases that you may be used to using. We're going to talk about a little bit on some real world use cases where we have used TigerGraph to help actual customers enhance their supply chain. And then we're going to take a look through one of our starter kits and take a look at what an actual supply chain graph could look like, and hopefully be able to leave you with a good foundation to be able to start looking at how you could implement a graph into your supply chain, or hopefully give you some ideas about how some of the broader use cases of graph. And we'll touch a little bit on, I know this is IoT focused, so we'll focus a bit on how coming improvements in IoT and how they're integrated into the supply chain, and how that additional data will only help improve our graph efficiency later on down the line. So one of the first things we will be, if you would like to try out the live demo, you're more than welcome to create an account at tgcloud.io. It's entirely free. It allows you to spin up a TigerGraph Cloud instance, and you can pick from any one of our starter kits or even just a blank graph if you want to try experimenting around with your own things. So feel free to go ahead and create an account there. All you need to do is give an email address, and I'll be talking about that a little bit more later on in the presentation when we get to the actual demo. So first, again, let's just talk a little bit about what graphs are and how they are different from the way that you are used to working with databases. So you may be used to a SQL or a relational database where you have a bunch of tables, and those tables have columns and rows. And each one of your columns represents an attribute of the data that's in the table, and each one of the rows is an individual entry of that data. And that's great for storing data. You know, your table represents a data concept, and your columns describe that data, and your rows are each one of those data entries. And that's great when you want to just store information and if you want to be able to retrieve it and access it. But when you want to look into deeper insights, that's when things start to get a little bit trickier with that. You know, you used to start writing joins to join your different tables together, looking for primary and foreign keys, and you start ending up building these SQL queries that get very complex and very inefficient when you go to run them. So the easiest way to think about graph is essentially a SQL database with pre-computed joins. So in graph, what we do is we take a look at the concepts that our data represents, and we really focus on how they relate to each other. So in this example on the screen here, we have a customer who places an order, and they use a payment method to pay for that order, and that order is getting shipped to a location where they exist at. These would all be separate tables, more or less, in a more traditional database. We would have to do these joins to figure out where a customer lives, or potentially what orders a customer had ordered. But if we wanted to look at something more advanced, like this order ships from a certain location, and this customer lives in this certain location, how do we optimize what location we can ship from for this individual customer for any of their orders? Or even better, this customer is ordering these products which come from two separate locations. How do we manage that supply chain and make sure that the customer is getting their order both on time and most efficiently in terms of transportation and shipping costs? So to do something like that, you can already see how you'd have to start writing all of these different joins to relate all of these data concepts together. But with graph, that's just already there. Your data, when it's loaded into the graph, has these linkages, these edges, as we call them in graph lingo, that connect all of these nodes or vertices together. So that way, when you go to traverse, when you go to write your queries, those edges already exist and you can simply traverse them. So it makes writing your queries very easy, because instead of having to say, look for this foreign key in this table and then join that with this table, you just say, go from customer to order to location, and you're done. You get all of the information along the way. In addition, there are different types of graphs. The main graph that we'll be talking about in this is a property graph. So what that means is that your vertices here can also have attributes to them as well. So just like we were talking about before, where your SQL, your table has those columns which describe, the contents of that table, just like that with a graph, our vertices can have attributes which provide more information about them. So a customer could have a first name, a last name, an email address, all sorts of information like that. A payment method could have details of the payment method, how much did it cost, what was the bank that it came from, or the credit card account, so on and so forth. But additionally, we can also add those attributes to our edges. So in this example here, we see someone placed an order, and we have the date that that order was placed on stored on the edge. So that way this order can exist as its own entity, the payment exists on its own entity, and the relationship between them, you paid for the order with this payment method, that is now our edge that connects those two together, and we can store information along there as well. That's just kind of a very basic overview of graphs and how they are different from the traditional relational ways that you may be used to thinking about data. So let's take a look into an actual real world example here. So Jaguar Land Rover is one of our customers, and we've been working with them to help improve their supply chain. I'm sure, as all of you are aware, over the last couple of years, there have been a lot of disruptions to the supply chain due to COVID and other factors just in the world in general. And because of that, I'm sure we've all seen the scarcity of the items that we want to purchase or the increased prices due to these supply chain issues. So Jaguar Land Rover didn't want to have to deal with that as much. They wanted to be able to stand out against the crowd in terms of being able to manage their supply chain and not having it be impacted by these real world things going on, or be able to respond quicker rather to real world changes. So first we have to understand what an automotive supply chain looks like, because you might just think it's parts go in cars, and that's great and all, and that is part of it. But a lot of it that goes into it is actually way before the supply chain even starts. Cars are obviously expensive things to build and expensive things to purchase. So you don't want to build more than you're going to sell, and you don't want to build fewer than there's demand for. So there's a lot of sales forecasting that goes into designing a new car. How much of this type of car do we expect to sell? And not even just the type of car, but the trim line, the base model one, the one with the leather seats, the one with the sunroof. You have to figure out how many people do you think are going to buy each trim of each individual vehicle. And all this forecasting, this isn't necessarily supply chain, but you have to look at historical data, order data, the way that the world is going, how many people are buying, other brands of this, of SUVs, to try and figure out, how many people are going to buy our SUVs. So that in itself is kind of its own graph problem. It's a little bit aside from the supply chain issue, but I can kind of touch on that after we're done with the supply chain stuff, because that was also a big factor in this. You have to be able to accurately predict in order to properly manage your supply chain. But the big problem with this, or at least the big penalty that can incur for a car manufacturer like Jaguar Land Rover is when you're designing your vehicles, when you're having the parts made, you go to different manufacturers and you say, we need this air filter housing, we need you to make this. You have to know how many of them you need. You can't just say, we need you to make these, we'll put in an order for however many. You need to say, we need 10,000 of these, right? And the issue then is, if you don't end up selling 10,000 cars, well, now you've got a bunch of extra of these things that you paid for. But even worse, though, is if you sell more now you don't have enough supply. Now you have to wait, you have to put in another order, you have to wait for them to get to their manufacturing cycle where they can actually produce those for you. You're in a line of a bunch of different customers who are getting things made by the same manufacturer. So you now end up with these huge delays, or you end up paying extra money for things that you don't need. So you can see that in both of those situations, you are losing money if you do not nail this forecasting down. And that's where graph can really start to come in. Because all of this data exists in different places in most companies. Most companies don't have one central database where all of their marketing data, all of their sales forecasting data, all of their supply chain management data, all of their product design data, none of that all lives together because there's no reason for it to in the past. But because of graph, because of the ability to take all of these discrete data sets and combine them, like we saw before with those edges between all these different parts of the business, now we can gain a much more holistic view of our supply chain, of our manufacturing process, of what people will be ordering in terms of our product. And suddenly, with all that extra information, you're able to look at much more than you were before and make much more intelligent decisions. But it's not just the thought behind the decisions that matters, it's the speed. So when you have to do, like Jaguar Land Rover in this use case, had 12 different data sources with 23 different tables across them. So all of this before had to be compiled by hand. All these complex SQL joins had to be written every time they wanted to look for new topics in that data. And this whole supply chain process for them for figuring out any change to their supply chain took about 3 weeks through the traditional method that they were using before. But once we were able to step in with graph and we were able to connect all of those different data sources to each other, once we were able to start looking at the relationships between those different tables, between those different suppliers, between the different orders and car models and car parts and everything, then they were able to just write queries to extract this information. Instead of having people just comb through the data and put together these reports and present them at meetings, you just run a query now, and it gives you the output with all of your adjusted values for how your supply chain should adjust to these changes that you've made to your forecasting or to the availability of certain parts. So instead of now something happens, we have to adjust our supply chain, we'll have an updated supply chain in 3 weeks. It's now something happens, we have to update our supply chain, we have an updated supply chain in 45 minutes. So I think you can start to see the money savings that happen there, not just in terms of human labor to go from 3 weeks of human labor to now 45 minutes of a computer running, but just the response time that you can have there. You now no longer have 3 weeks where you're missing out on orders because you're waiting for your supply chain to update. Now you can update that supply chain immediately. You can start ordering parts from a different supplier, or shipping cars to a different storage location, whatever the disruption may be. And that really allows you to gain a lot more that you missed out on earlier, just because you can react quicker. And that's really what a lot of supply chain is coming to nowadays, is that in the moment, you don't want product. Anytime that you have product sitting on a shelf, you have to pay for storage, you have to pay to put it in a warehouse. So the quicker that you can go from a manufacturing plant to assembly line to finished vehicle to customer's hands is, you reduce the amount of time that you have to keep things just sitting there doing nothing in storage. You're really getting to that on-demand manufacturing, which is something that is very much coming up. Hopefully in the future that we'll see a lot more, especially with these improvements in supply chain flexibility. And as we'll be talking about in a little bit, the integrations of IoT technology into supply chain, the ability to track these products as they're being shipped around to different locations, the knowledge of where they are in the manufacturing process, and things like that. So it's very interesting to see how all of these different parts of all of these different cars from all of these different manufacturers all end up converging together into a vehicle that then has to go through its own sort of supply chain to go from that vehicle to the hands of an actual customer. So again, this kind of just another example of all the different touch points that we have in any given supply chain, from the order to the establishment of what people actually want. You start with you get an idea of the market, you design something for the market, people start placing orders, maybe those orders aren't as much as you're looking for, you're able to adjust now your product before you start your manufacturing cycle, you bring it into manufacturing, and then your supply chain really kicks off due to all of those updates. So it's very nice to see these natural connections that we have between order, product, design, parts, suppliers, it all very easily connects together in a manner that lends itself to graph nature very easily. So one of the things, like we were talking about, the big advantage of graph is just this different way of looking at the data. So instead of having to have all these different tables with all these different private and foreign keys, we just have these vertices that we can quickly traverse between due to their relationships to each other. So it's great to be able to look at all of the parts of something in one place and visualize exactly how they connect to each other and how that affects different parts of the completed vehicle or going back. So it's really cool. One of the things about graph is that when you think about supply chain, you think about it in one direction, right? You think about the manufacturer makes, your suppliers make parts, the parts get assembled into vehicles, and then those go out to the customer. And a lot of the time supply chain goes in that direction. But with graph, we're able to now look backwards. So normally you would think about a supply chain like you have a disruption. One of our manufacturers is no longer able to supply chips. We have a chip shortage. So how does that affect down the line? Looking forward, how that affects. But with graph, we can also look backwards. What other manufacturers make these chips? What chips have similar functions that we can work into our design that we could start using instead of having to rely on these things that we no longer have access to? We have customers who are ordering a bunch of vehicles of this trim level, but not of another trim level. And we have a surplus of these parts. So how do we make sure that we're making vehicles with those parts in them? So we run through those and also making them of this trim level. So that way we know that we are making vehicles that our customers want to purchase. So it's very interesting with graph to be able to kind of look both directions in your supply chain. And that's really one of the big advantages that it offers, and something that can really help set you apart from the competition when you have the ability to be bidirectionally flexible with your supply chain. These next couple of slides will just kind of talk about a little bit those graph linkages. I'm going to go through these relatively quickly, and then we'll hop into the demo so we can start talking about some actual showing off some actual graph stuff going. But this is kind of an idea of what you're normally dealing with when you have all of these different tables that you have to work with, tables that reference themselves. We have these in graph or in a database. This might be a part, and that part relies on another part in order to create an assembly. So you have this list of parts, and you have these links that tie them together to either these assemblies or to the other parts in that assembly. And you have these self-referencing tables that you then have to write queries to parse through. In graph, you can have types of vertices that link back out to themselves. So you could have a part, and you could say part relies on part, and it links back to another part that is relied on. Sorry, this will all be much more clear with the visuals from the demo, but just kind of getting it out there. And then again, with more traditional tables, you have the idea of heterogeneity, right? So you have to have a different column for each attribute of your data. But if that column isn't necessary for a particular row of data, then you're going to leave it blank. You're going to leave it null. You're going to have this blank information. You're going to have a very wide table when you don't necessarily need to. With graph, you can just create a vertex type specifically for engine, for wheel, for whatever your specific part is. And now you're able to maintain that this is a wheel within your graph. So that way, when you say, I want to look back at this, you don't have to look through a bunch of columns and say, okay, this is a wheel, so therefore we need to go to the wheel info column. It's just, this is a wheel, here's the info about our wheel. This is an engine, here's the info about our engine. It's all in one place, stored in that vertex. So that way you don't have to worry about these complex tables. Additionally, graph is very flexible. So if you have a situation like this, where suddenly we've added this component of electric, we now have an electric vehicle, an electric engine, a motor, so it's different than a regular engine. Well, now we have to add a whole nother column to our traditional table that stores that info about our electric motor. And because of that, now we have to add that extra column to all of our parts. So we essentially have to change our entire table just to add in a new type of element. Graph, not an issue. You create a new vertex type, you add it to your graph. You don't have to reload any of your data. You don't have to modify anything that was already there. You can just load in your new data for that new vertex type that you created, and you're good to go. You can see how it integrates with the rest of the graph, and you don't have to worry about having to go back and adjust your tables or even write new queries. Your old queries will still work. You just have to now incorporate that new vertex that you added. So it's very easy to have a flexible schema and to make those changes on the fly. Depth as well with these link depths, put parts, part relies on part, which relies on another part, which relies on another part. Trying to reference and that all in one table is messy, to put it simply. So doing that in graph, like I said before, you just have those self-referential edges, and it makes it very easy to say, I want to start at this part, and I want to go all the way down the chain to the final assembly. All of the parts in between, I don't want to have to count how many there are. I don't want to have to worry about doing that. You can just, with a graph traversal query, you can just say, start here, end here, get me everything in between, no problem. So it's very easy to do complex traversals like that. And then again, many-to-many matching, something like with a table, you again have to do all of these complex joins to get all of that information. Again, with graph, it's just a single vertex, and instead of one edge coming out of it, there's two or there's three. And it's as easy as that. And when you want to traverse, it will select all of those edges if they specify the pattern that you're looking to traverse. And additionally, there's kind of the concept of directionality. In a traditional database, you have that, directionality. We can go from foreign key to primary key, but going backwards is a little bit tricky. With graph, those edges, they just connect two things. So you can go in whichever direction you would like. It makes it very easy to say, this part goes in this assembly, or this assembly has these parts in it, whichever way you want to go. So, oops, a little bit farther. So I guess now we will switch over to the demo. I'll show you one of our TigerGraph starter kits. So we have a bunch of, one second. We have a bunch of starter kits for you to be able to choose from. Let me just go through setting that up. So I have one already running, so we don't have to worry about that. But I just want to show you if anyone's following along and would like to set up their own example to try out. So if you head to tgcloud.io, this is our cloud platform. You can see your list of solutions will be empty, but if you go to the My Solutions tab here, you'll have, sorry, I just need to drag some Zoom stuff out of the way. There we go. You'll have a list of empty solutions, and you can just select Create Solution up here. That will give you this interface where you can select from any of our starter kits. So you can see that we have a bunch of different starter kits here. The one that we'll be using today is supply chain analysis. So you can just click on that, and any of these you can just hover over and it will show you exactly what is in that. And we have some more information on these starter kits on our website if you want to dig around and really see what data sets are used for each particular starter kit. You can go ahead, select that, click next. You can select where you would like to host it. So we do offer all of the three main cloud platforms that you can host on. And we do as well have that free tier for anyone who creates their account. So you can go ahead and select whichever your preferred platform is, select free tier, and then you can just click next. And then from there, you'll just set up your instance where you could call it something like supply chain. And then you can just give it a username and a password as well. Or sorry, just a password. The default username is TigerGraph, and the default password is also TigerGraph, all lowercase. So that's just what I'm going to leave mine as for the sake of this example. And then you'll want to give it a subdomain. This is just where you'll be accessing your solution. So we'll call this one supply chain. Then you would go ahead and hit next, and you'll get a nice little summary, and you would click submit. And then it would start spinning up your solution. And within about 2 or 3 minutes, you'll be able to access your solution. I'm not going to do that because I already have one running. So you'll see that when you start up any one of your starter kits, you'll first start in the global view. It's kind of is more in-depth with TigerGraph, but you can have multiple graphs in one solution. So we'll just want to select from global view into our actual demo graph. Now let's take a look at what this graph represents. So this is our schema. And a graph schema represents the topics and the relationships that are going to be shown in the graph. So these are vertex types. So each one of these represents a particular topic, but for each one of these vertices, vertex types, there can be multiple individual vertices. So think of these, each one of these vertex types, kind of like a table in a traditional database, whereas later on when we're looking at the actual graph, each individual, for example, each individual supplier vertex would be a row in that supplier table. This will make more sense when I start going through it, but for now, I just want to kind of describe what our basic graph is representing. So here we have products. Those products have names and they have prices, and they can be used by other products. So multiple products can be combined to create a new product. And that's what this edge is showing here. That's that self-referential edge that I was talking about before, where a product can, reference another product. Additionally, those products are stocked in different locations. So we have these different locations that they're stocked at. Those products can be ordered through orders. So these orders tie back to products. And then sites are different manufacturing areas. So these sites produce different products, and also they can deliver products to other sites. So this is something that we'll see where there might be a site that produces rubber and there might be a site that produces aluminum, and then they both ship them to one site, which combines them into tires and wheels. So that's kind of the idea that we're representing here with this delivery address. And remember that this is between vertex types. So like I said, we're not going from site A back to site A. This could represent, for example, site A to site B, both of those being of the site vertex type because they both represent manufacturing sites. And then lastly, we have a supplier, which supplies raw material to a particular site. So that way they can produce a product, which can then be used by other products or ordered by customers. So that's the basic idea of what we'll be storing here. And let's take a look at just kind of poking around in the graph, seeing what that looks like. So like I said before, those that we were just looking at were vertex types that represents kind of the overall structure of our graph. Now we're going to be looking at actual vertices, the actual data in our graph. So if we select some products, we'll see that we have some products that appear. And we can just force these into these, force these into the center of the screen. But we can see that we have a bunch of different products. They have prices and they have formulas which determine their price as well. That we'll get into a little bit more when we look at the queries, but for now. But we can see, so we have belts here. And if we double click on one of these, we can now see its connections that it has in the graph. So we can see that site 9 produces belts. Those belts are used by tires. And we can see that steel rods go into the belts that then go into the tires. We double click on, say, for example, steel rods, we can see the site that creates those, and we can see what else those steel rods are used for. And if we were to double click on more things within this graph, we can see those different connections. So site 5 ships steel rods to site 9 so they can produce belts. And then site 2 takes belts from site 9. And let's see what site 2 makes. And site 2 produces tires. So we can now start seeing this supply chain within our graph. We can see the different elements and how they relate to each other. We can see the different sites, what they produce, and how that affects all of these other parts within our graph. So that's kind of a basic idea of what that looks like. There's obviously a lot more that we can do here, and that's really where our queries come in for a lot of the power that graph can offer. So we'll do, we have a couple basic queries. Impact analysis, I think, is one of the better ones to really show off the graph capabilities. And what this will do is assume that we had a site where there is a natural disaster or something where the site was no longer able to produce the product that it was creating. And what this query will do is return down the line all of the other parts of our supply chain that are affected by that one site not being able to. So if we look at what we had before, where we had, for example, site 5 produces steel rods, and those steel rods are used by all these different parts. Well, if something were to happen to site 5, then that's going to affect all these other parts of our supply chain. So obviously we could do that by clicking around, but in the real world, that's, you don't want someone clicking around in your graph. You want to just be able to run a query where we can say, oh, interesting, where we can say the query is not installed. Interesting. Oh, sorry, that was the wrong query anyway. So we'll take 1 second. But basically, yeah, the large point of graph here is to be able to take those manual processes that we normally had to do, because graph is really about those relationships in data. And if you think about it, that's how people think about data. We don't just think about, oh, this is, I don't know, this is a phone. You know that this is it's a Samsung phone. It's running Android. It has all of these different, it has a screen on it with a camera. Whereas if you just say phone, it doesn't mean anything, but to your brain, it starts putting all these different features, all these different parts together that describe that phone. And that gives it more context to the information. And it really makes it feel like that's a real world object rather than just, phone. It's, smartphone. It's got all these different things. It's the way our brain thinks about it. So why shouldn't our data be thinking about it like that as well? We have all of this context, which we use to make more informed decisions. So our data should be stored in a way that maintains that context. And that is what graph does with those relationships. So let's try running this. I don't know why this query isn't running. We'll install this one as well. But basically, there's a lot that we can do with this graph. So right now, this query is going to do impact analysis of stocking. We could look at price prediction. So if, for example, we have a supply chain shortage from one of our manufacturers, the cost of rubber is suddenly going up, how much will that affect the end cost of our car? the rubber is used to make the tires. The car has 4 tires on it. So any of this increased cost in the manufacturing process is now going to percolate down into the final product that we are creating. And we need to be able to easily see that. And with these graph queries, we can do that. So just give this one last second to finish installing. But there we go. So we can run this query. We want to try, let's try site 5. Oops. And max depth right now, that's just going to return, that's how far down our supply chain we want to traverse. That's just something for the purpose of this query. But we can see now, this is all of the aspects that are affected by site 5. So we can see all of the different sites that site 5 delivers to, all of the different products that are produced not just by site 5, but by any of those sites that site 5 influences. Obviously, this graph view is great for people looking at, but in the real world, you want an application to read that. So the actual output of this query is JSON, which can be easily ingested by any sort of application that you might have in your pipeline that could be hooking up with the TigerGraph database. So that, I guess, is really kind of a very high-level supply chain view. The thing that's going to be very interesting going into the future with the integration of more and more IoT technologies, as we start being able to, we can already track packages on trains and, in trucks and things like that. And that's all very easy to say, left location A, went to location B. But now we have the ability to kind of sense that en route. You get the notification that your Amazon package is 10 stops away from being delivered to your house. There's no reason why the rest of our supply chain can't do that as well. And with that additional data, now do we no longer have, site A was affected, or, site 5 was affected by a natural disaster. Now we can say that there's expected to be severe weather on the road between site 5 and site 4, and that's going to impact our supply chain. We have this additional context that we're getting by bringing in this weather data, by bringing in this traffic data of where the vehicle needs to go between site 5 and site 4. And we can say, we're going to experience delays because of this weather that hasn't happened yet, but will affect our shipping route. So it's very interesting to be able, once you start bringing in all of these other sources of data, because that's really what Graph is great for, is combining all these different sources of data and looking at the connections that they have with each other. So once you can start bringing in, your weather data, things like fuel efficiency data, things like traffic data, all of that into your supply chain, now you can make much more accurate predictions as to exactly how things will be affected down the line, as to what your cost will be for each and every step in your supply chain and how that affects the cost of your end product. And additionally, how any of those impacts might affect customer sentiment or customers want to order your product. So there's definitely a lot of possibilities for expansion from going from just something that represents your supply chain to something that brings in all of this external information to further augment and enhance your supply chain. So I know that was a lot. I'm going to go through the questions really quickly. If anyone has any questions, feel free to ask them. Happy to answer any questions about specific supply chain use cases, about Graph in general, the TigerGraph product, or really anything involving this type of information. Let's see one of the questions here. For supply chain, how we get connected with external data. Yes, so that's kind of what I'm talking about with this IoT type integrations. Obviously, a lot of this data is going to be held, sorry, I realized I just read the question, but didn't read it out loud. But the question is essentially, how do we get this supply chain data? How do we get the data from the manufacturers about these products? And the answer is, it's really something that you need to be integrated with your manufacturers and with your supply line right now. There's not really any public APIs that a lot of these manufacturers have that say, oh, hey, we're running 4 days behind on this current production cycle. They know that they're running behind, but that's not publicly exposed. So that's the type of thing where you'd want to work with your partners, with your manufacturers, with your suppliers to say, hey, we know you have this data because that's how you manage your supply chain, essentially, how you create your things. So how can we get access to that data So that way we can help both of us out, because it's really about that. It's not just we recognize you have a delay. How do we figure out how that's going to affect us? But how can we schedule our orders in the future so that way we can look for areas where you have less production. Maybe you don't have as many customers right now, your machines aren't running as much. So now we can really put in some orders. Maybe we can get a cheaper price because we're helping you run your machines at times when normally they'd be down and you wouldn't be making any money. So maybe now we can both win off of this situation. So sorry, I don't have like a definitive answer for that, but I think that that's one of those things that we're going to see improving a lot over the next coming years as this technology starts making its way further into the manufacturing space. And I think even more, the real driving force behind it will be the producers who are the people who want to make products, really demanding that their manufacturers and that their supply chain provides this information. So that way they can work it in their products. Because I think that a lot of companies, like we saw with Jaguar Land Rover, they're certainly not our only customer that's working with supply chain, and they're certainly not the only company working with Graph for supply chain. So, so that's really where that comes from. Not all options visible on this. So you're most likely not all options are visible in the left panel. Is that a paid service? So most likely you are in your global view. So if you click that drop down and you select one of your graphs. So for this example, you would not be able to select these. However, once you select your demo graph, all of these options will be able to become selected. There is no functionality limit to the free tier of TigerGraph. The only limit that is implied is the size of the machine that it's running on. So you only get 50 gigs of data storage. And the only other limitation is that it will go to sleep essentially after an hour of an activity. So if you haven't used it for an hour, it will go to sleep and you will have to manually wake it up in order to begin using it again. But other than that, all functionality of the TigerGraph product is fully available in the free version. Let's see what else we have. Yeah, so does anyone have any more questions? Anything you'd like to know about, sort of what the future of supply chain looks like, about the Graph product in general, Graph in general?
Maybe also if anybody has any specific use cases that you're using right now for IoT or AI, and you want to put that in like the chat, or then maybe Dan can talk to that too, just to make it more interactive. We're so excited that you all are here. Nikhil's done such a good job of building community that we really would love for you guys to participate and think of it as an opportunity to ask the expert Dan some questions.
Yeah, happy to talk about other use cases with IoT. Question here, does LinkedIn use TigerGraph? I don't believe LinkedIn is one of our customers, but LinkedIn is a great example of a graph data set. It's all relationships between people between companies, messages and posts by people. So that really falls into one of our big, another use case of ours, which is kind of that social networking and that social interaction. So yeah, graphs are fantastic. I believe that we have a few starter kits actually focused around social networks. So feel free to check those out and you can definitely spin them up. Oh, one thing I did forget to mention about these solutions is when you do pick a starter kit, at the very beginning, your data is not actually going to be loaded. It exists in the graph. You will just have to hop over to this load data tab and then click the play button up here once it becomes available. And that will just take all of the data and load it into the graph. The starter kit just starts with a bunch of files on it and everything's mapped up, but just due to the way that spinning up the cloud service and the persistent storage goes, you just have to load the data the first time. So you'll just have to click that little play button in the top corner of the loaded data tab to get all of your data to appear there.
I also too, I didn't know this, Dan, but we were on a webinar earlier this week, and I guess LinkedIn used to use TigerGraph early in the, like Renchu Song, who's does their graph design for their graph studio. He mentioned that a while ago because he's been here for like 6 years. They used it to kind of test it out, but he doesn't think they're using it anymore. So it was just something new that I had no idea about. That was interesting.
Yeah. Yeah, that's great. And that's not because they're not using Graph anymore. Most likely it's because were working on their own Graph product and spun up their own internal LinkedIn Graph that they are using. But a lot more companies are transitioning to Graph just purely because of these benefits that it does offer when you have all of these data sets, all over your company, and when you're able to bring them together. I mean, we're even using it internally to take a look at how our community members are then turning potentially into customers. How do we enhance that pipeline? How do we look at what's drawing people in? What are their interests? What are our potential use cases? Who do those people work for? How do we, align all of that sort of stuff? So Graph is really great for taking those separate data sources and really getting the most information out of them. Financial fraud detection, is TigerGraph used? Yes. How many, was it 7 out of the 10 largest banks in the world use TigerGraph for fraud detection?
Yeah, I think that's correct. And we're even more. And you can even think about it too for individual businesses, kind of connecting it like building your own social graph. But yeah, and we just did a webinar on that earlier this week that we can share in a follow-up email with you if you're interested, or it's on our LinkedIn. And it goes through how we detect the fraudsters. We have a no-code solution too that we designed that you can go in and look at too.
Question here about Jaguar Land Rover using cloud or on-prem. I'm not actually sure if they're cloud or on-prem, but as far as the limitations, we are currently working on the LDBC, which is the large graph data benchmark. So it's essentially a huge benchmark. We've completed the 1 terabyte data set, and we're currently working on the 36 terabyte data set. And I believe that is all running in cloud infrastructure. So as far as limits go, for TigerGraph Cloud, the limit is your credit card, really, because a bigger machine will run up the cost. But we do also offer the option to run this on-prem. If you go to the TigerGraph website, you can click on download, and you can just get essentially the same free license as the cloud provides, but you can just run it on any machine that you want. It'll either provide it as a Docker image, or a bare metal install, depending on what you would rather run. So if you have some server somewhere with 64 gigs of RAM and you want to run TigerGraph on it, you can do it entirely for free if you download that package. So that's pretty great. You're using Docker image for learning? Yeah, that's great. Fantastic to see. We also have recently our machine learning workbench, which is it's built on top of Jupyter Lab. It connects directly with TigerGraph. So one of the great advantages of Graph and machine learning is that context, like we were talking about. Whereas machine learning, obviously, the more data you have, the better results you can get. But something also about that is the quality of the data. So if your data, you can have a lot of data, but if that data is no good, or if that data is very shallow, then you're not going to get the best model. But now, as soon as you can start bringing in that data, as well as the context that you can get from all these different edges that connect related aspects to your data, now you can suddenly start getting much more granular, much more refined, and much more accurate machine learning models out of your graph. So it's very cool to see the improvements that we've seen using graph neural networks on top of graph databases to really enhance machine learning. Typically in ERP, there are BOB adding tables to capture the structure and process. How does that translate it? I'm not the most familiar with ERP or BOB. I guess, could you elaborate a little bit on those? Can we have real-time connectivity with our internal data source in TigerGraph? Yes, entirely. TigerGraph, you can either load files through our traditional loader, like we're kind of seeing here, CSV files, JSON files, normal data files, but we also have a Kafka streaming pipeline set up. So you can just stream data in through that Kafka connection, whatever live data you want. I actually built a demo a while ago. We'll be talking about it in 2 weeks with the IoT demo, where I had some Arduinos, or ESP32s, that were just connected over Wi-Fi and streaming data directly into a TigerGraph instance, just using TigerGraph's built-in REST endpoints. Webinar for, yeah, it'd be great if we could share a webinar for fraud detection. Kelly, do you want to pull up a couple of those links?
Yeah,
I know we have so many videos on the topic. I think you'll really be interested.
Yeah, I'll share a list of it and even in the follow-up email. But have you heard of anything that we've done, or maybe you can give some use cases on scam and phishing? I know we have a lot on cybersecurity that I can share too, but you may have known some cases how Graph works in those situations.
Yeah, so we have a demo where we tangentially talk about phishing. I believe we have a demo, one of our fraud demos talks about scam phone calls and how you can recognize fraudulent phone calls based on the past phone calls that they've made. So I believe that this was a data set from one of the major telecommunications companies in the US, and it was looking at phone numbers versus the amount of calls that they made and the calls that they received. So a lot of these fraudulent calls, there's a lot of calls that come out of them and they have very short durations because most people pick up the call, they realize it's a spam call and they hang up the phone. So suddenly now you're able to visualize that we have this one number with a bunch of calls coming out of it, which all last, 30 seconds or less. And no one calls it back because, it's a spam number. Why would you want to call it? So now we can see from that pattern of all of these short duration calls with not many calls coming in, that this is most likely a fraudulent number or a spam number or some sort of phishing type thing as well. But a lot of the fraud detection also takes sort of that same concept in vain to look at. For example, we have a good one that shows off money laundering rings. So, person A will purchase, you have to launder the money, you have to wash the money through all these different fronts. So a lot of what that involves is the money will get transferred from account A to account B to account C to account D back to account A, and that's your clean money now. So looking at those patterns in those traversal rings of how fraudulent transactions happen, we're able to easily identify some of those fraud rings and some of those money laundering rings as well, just by looking at the patterns in those connections. I'm not sure what the HANA database is. I guess I'm not familiar with that. So, but what I will say is that TigerGraph has anything that you can do in TigerGraph, anything I've showed through this demo, through this web interface, is available through REST APIs. So if you want to call a query from a REST API, you can do that. If you want to adjust your schema from a REST endpoint, you can do that. If you want to upload data from a REST endpoint, completely free to do that. So while we might not have, we are obviously always trying to build up our the amount of connectors that we do have for all of these different databases and everything. But for everything that currently doesn't exist, there's REST endpoints. And we're also more than happy to hear what people are working with, so that way we can start building out connectors for that type of thing. We do have a very good connector for Python, TigerGraph, which allows you to do all of your TigerGraph functionality directly from Python. I use it on a daily basis, and it's one of my preferred methods besides this interface of kind of, I like the interface for the visual aspect. So when I'm first setting up a graph, when I'm first designing my schema, when I'm first doing all of that, I like to be able to visually see it. But obviously, that's not the best for a production use case where you need to just be able to do everything via code. So you can just, boom, you can just do that via REST endpoints. Yeah, the Python library is PyTigerGraph. It's the documentation page. You can get to GitHub, and I'll share that. And you can just obviously just pip install PyTigerGraph, but here is the link for that. And we have a bunch of great tutorials on PyTigerGraph on our YouTube channel as well, kind of going through everything. An example of connecting TigerGraph with Kafka. I don't have one offhand, but we can definitely send that out afterwards, as we do have it in our documentation though, pretty thoroughly documented. So you can definitely check that out and see exactly what you have to configure in order to get Kafka hooked up. But it does support that real-time streaming and everything. So it's great to see that. How can I use this to create a network of IoT nodes and assign addresses from them in case one of the nodes fails? Will they still support redundancy? Interesting. So I guess looking for a little bit more info on that. Are you talking about like TigerGraph redundancy or the IoT redundancy? Because the IoT redundancy could certainly be done with Graph, where you can kind of have those connections and say, this device and this device do similar things. If this device is no longer there, then we can fall back to the data that this device is collecting. And that's something that can easily be done with graph to be able to see those relationships between those different devices and where other devices can kind of step in. And this is something that we'll be talking about a little bit in 2 weeks with the concept of digital twins, because that's really one of the big areas where these graph data sets can really help with IoT and getting that information in there. Can TigerGraph be used with data warehouses? Yes, it's going to come down to how you get your data out of your warehouse and how you want to ingest it into Graph. Graph supports a bunch of different ways of ingesting your data. We've talked about, or I've mentioned the CSVs, JSONs, Kafka loader. We also do have a relational database importer that you can use to import your MySQL, your SQLite database directly into TigerGraph, and it will assume the schema. The schema will hold up to what your initial database showed, but you're not loading it into Graph so you can get the same insights that you could get before. So there's obviously more that you can do to enhance that schema to get more connections between that data, but it is very possible to just directly hook up a TigerGraph instance to migrate from relational database. So you can do that right there. Another great thing, just a really quick kind of off the, but like I talked about everything that we did through this interface. So I didn't really walk through it. I think in the last video, we had walked through really setting up your first graph solution. But like I said, everything that you can do through the interface can be done through APIs. And even cooler is if you just click export solution, this will give you a file with just all of the GSQL code that you need to execute in order to directly spin up this solution. So TigerGraph does have its own query language, which is called GSQL. And GSQL is used for not just writing your queries, but also for modifying your schema, setting up your schema, loading your data, creating loading jobs. But obviously all of that, if you're just used to the interface and clicking around, jumping into GSQL can be pretty complex. So if you create something through the interface, you export your solution, you can now start looking at that GSQL and you'll be able to more easily understand it because you have the context of your graph in the interface, as well as the code written out that describes exactly how to create that graph. Let's see. Build graph patterns. So build graph patterns is essentially a way of writing queries without having to actually write queries. So here, I'll walk through really quickly, I know we're over time, what a query traversal looks like. So for example, here, this is one of our graph select statements. And what we are saying here is go from a site that we're calling affected site, traverse through an edge called produce, and end up on a product. And if we look at our graph schema here, we can see that that's essentially describing going from site to this produce edge to a product. So that's how we write it in GSQL. But with build graph patterns, we can easily just say, we'll just make a test pattern. And we can say start from a site. Sorry, I just have all the Zoom stuff over my screen. Start from a site and go to a product. And now we've essentially just written that same select statement just visually without having to actually write anything. So it's a very easy way to kind of start exploring your graph programmatically if you don't want to jump right into writing GSQL code. So yeah, I think we'll call it there. I'll hand it back over to Nihil and Kelly to wrap it up. Feel free to message me if you have any questions. You can send me an email, or Kelly will provide some links where you can get in contact with us through either our community site or our Discord, I believe.
Okay. And yeah, and I'll send, there's one more question about IoT, create a network of IoT nodes and assign addresses for them. If you don't have time to answer them now, I know it's over and I appreciate you taking the time, Dan. It's
Oh,
1:30 a.m. for Dan, so I really appreciate it. But we can always send out the answer to that question because that's a really good IoT related one that maybe the registration, everybody on the list would want to see, unless you want to answer if it's quickly now.
yeah, I believe I touched on that one briefly before. It kind of depends on how you're looking to, in case the node fails, for redundancy. So create a network of IoT nodes and assign addresses to them, certainly possible. That's very much along the lines of what I did with the demo I'll be showing off in 2 weeks, where I created devices, assigned addresses to them based on where they were located, and had them gathering a bunch of uh, ambient data. But yeah, you can certainly maintain that relationship and say, these two devices are essentially doing the same thing. If this device fails, I want to roll back to this one. You can maintain that connection between them very easily with Graph.
Okay, awesome. Well, thank you. And then if you want to just show your slides really quickly, I put my email and your email
Yep,
on.
sorry.
And then Nihil, I know this is, you hosted it, so thank you again for including us. We're so, glad to be part of your community. I like the dialogue, so hopefully the next one we can do more of these. So yeah, to get our next webinars, we have another fraud one. So the payments process, do you know who has your money, the impact of risk on all of us? So that's going to be in London. So again, if you want to register for these, even if you can't attend, we'll email you the information. On 4:30, we have one buy now, pay later with Expiro that we can get the link to. We're still getting it. And then on 4:30, we're having a follow-up on this that Dan's doing. With how to use TigerGraph for IoT. And then on 5/24 and 5/25, I'll update the date. We have a Graph plus AI day. So we're going to do business use cases. So that's where we'll go through some more on these fraud use cases, supply chain, retail. Not as much IoT, but we are going to, I think, do some cryptocurrency. So we're still getting the schedule out. But then the second day is our developer day. And that's really, really beneficial because it'll go through the actual design of how to use TigerGraph for different use cases. And Dan did an amazing job last year when we did it on like TigerGraph 101, and we showed how to connect to other systems. We did some for Plotly. And I know we have a lot of great surprises for those. So definitely sign up for that. And then last but not least, if you want to go to the next slide to get started in here, they have, we have a list of all the different places to get. Again, as Dan mentioned, we have a free tier, an enterprise, demos, get certified. There's more and more jobs that are offering TigerGraph. Just recently, JP Morgan Chase has 5 job openings for it. So, and then also join the community. So you can ask all your questions of Dan and the rest of the team and others in the community as you get started. So with that, thank you all so much for coming. I'll hand it off to Nihil. And again, thank you, Nihil, so much for including us. And it's great
Wonderful.
to see everybody.
Thanks so much.
Again, all the people that we've seen last time. I recognize a lot of your names. So thanks again.
Yeah, and absolutely great to have so many of you back. So Kelly, a quick thing on the next for the session happening on 30th of April. So those who have already registered don't need to register again, right?
Yeah, that's
but will they receive a separate Zoom link?
Yes. So they'll you'll get another Zoom link like you did today where it can go to your calendar and then you'll get a notification an hour early, just like you did today.
Okay, perfect. Okay, great. So wonderful. Hope all of you had a great session today. Daniel, Kelly, thank you so much for putting this together, especially taking time off on your long weekend. And thank you all the attendees. Please don't forget to mark your calendars for the April 30th session. It's essentially the same time as today, 2 Saturdays from now. And also, please make sure that you let your friends and colleagues know. It always helps to have, if you're thinking of using this in your company, it's always very helpful to have your colleagues also kind of on the same page as you. So the more number of colleagues that you can pull into these sessions, and as they get to know a little bit more about TigerGraph, all of you can kind of work together, think about it, and see if it makes sense to use it in your organizations. Well, okay, wonderful. Thank you, everyone. Have a great weekend.
Yeah, have a great weekend, everyone. Thanks again. Bye.
Thank you all.